Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. This is our last subchapter for chapter 2, integration. In 2.3, it is definite integrals. Next, the properties of definite integral. The first rule is when we integrate the constant c dx from a to b, it will be equal to c bracket b minus a, where the limits is from a to b, where c is any constant. So this is simple example where we integrate 2 as a constant here from 1 to 5. So 1 represent for a and 5 represent for b, and it will be equal to, okay, 2 here is the constant. We factorize outside and then we integrate, we will get x, and then we have to put the limit from 1 to 5, and then after that we have to substitute the limit into the function of x inside this bracket. So it should be 5 minus 1, and then we will get 4 here, and then after we times with 2 here, 2 times 4, we will get 8. Next, second rule here, when we integrate from a to b for function of fx plus or minus gx here, it will be equal to the integration of fx from a to b plus or minus the integration of gx from a to b. This is simple example. Okay, when we integrate 3x plus 8 here, where 3x here represent for fx and 8 here represent for gx, and the limits is from 1 to 5, and it will be equal to the integration of 3x from 1 to 5 plus the integration of 8 from 1 to 5. Next, the third rule here, when we integrate c fx dx, where c is any constant from a to b, it will be equal to, we may factorize c outside the integral symbol, and the integration for fx from a to b. This is simple example. When we integrate 3x squared dx from 2 to 8, we will notice it will be equal to, we may factorize 3 here. Okay, put outside the symbol of integration here, and then the function is x squared and the limit from 2 to 8. The next rules of definite integral, when we integrate fx from the limit a to a, it will be equal to 0. And we notice that here the limit here is a and upper limit also a. So that's why the value here should be 0 when lower and upper limit are equivalent. So this is simple example. When we integrate 7x cubed dx from 6 to 6, we notice the lower and upper limit are equivalent. So that's why the answer should be 0. The next rules, when we integrate fx dx from a to c, so the limit from a to c, it will be equal to the integration of fx dx from a to b, okay, from a to b, a here, okay, to b, and then plus the integration of fx dx from b to c, okay, where b is between a and c, and we will notice that here on our left side here, the lower limit is a and upper limit is c, and it begins from a to c. And on our right side here, it begin from A and then end with the limit of C. Okay, this is simple example when we integrate 2x to power of 5 dx from 3 to 10. It is equal to the integration 2x to power of 5 dx from 3 here. Okay, from 3 here and then to 7. And then plus the integration of 2x to power of 5 from 7 to 10. So on our left side, we will notice that the lower limit is 3 and the upper limit is 10. Example 14. Evaluate each of the following definite integrals. For part A, when we integrate 8x to power of 3 or x cubed dx from 1 to 5. Okay, first we may factorize A outside the symbol of integration. And then we have to integrate x cubed here. And it will be equal to x to power of 4 over 4. And then we have to put lower limit here is 1 and upper limit is 2. Next, okay, after we simplify 8 and 4 here, it will be equal to 2 here. Then we have to substitute the limit 2 and 1, substitute into this function inside this bracket, and it will be equal to 2 bracket 2 to power of 4 minus 1 to power of 4. And the final answer should be 30. Next, when we integrate 3x plus 1 over x cubed dx from 1 to 2. Okay, first, okay, it will be equal to the integration of 3x dx from 1 to 2 plus the integration of x to power of negative 3. This one we simplify from 1 over x to power of 3. Next, for our first terms here, 3x, when we integrate, we're going to have 3x squared over 2. And we have to put the lower limit 1 and 2. Why? For the second terms here, when we integrate x to power of negative 3 here, we should have x to power of negative 2 over negative 2. And then we have to put the lower limit 1 and 2. Next, we may factorize 3 over 2 here. Okay, 3 over 2 here, put outside, and 1 over negative 2. So that's why here will be minus negative 2. And then x to power of negative 2 here. Okay, we may simplify as 1 over x squared. Next, we have to substitute the limit, lower and upper limits here. First, substitute for x is equal to 2 here, x squared. So when we substitute 2 squared, it will be equal to 4. And when we substitute 1 here, x is equal to 1, we're going to have 1. So that's why 4 minus 1. So next, for our second term here, when we substitute x is equal to 2, so 1 over 2 square, so that's why it is 1 over 4. And then when we substitute x is equal to 1, so it will be 1 over 1 square, so that's why 1 over 1. So next, when we simplify, it will be 9 over 2 plus 3 over 8. And the answer should be 39 over 8. Next example, when we integrate bracket 1 minus x bracket to the power of 6 from 0 to 3. Okay, first, Okay, as we know, when we integrate bracket 1 minus x bracket to power of 6 here, okay, 6 here will be plus 1. That's why it will be equal to 7. And next, we have to put 7 on denominator side. Next, what we're gonna do, we have to differentiate inside this bracket. When we differentiate inside this bracket 1 minus x, we will have negative 1. So that's why we have to multiply negative 1 with 7 here, and it will be negative 7. And next, we have to substitute the limit. Lower limit is 0 and upper limit is 3. Next, we may factorize 1 over negative 7 outside this bracket, and it will be equal to negative 1 over 7 bracket 1 minus x bracket to power of 7 from 0 to 3. Next, we have to substitute the limit. First, we substitute the limit of 3 here when x is equal to 3. So that's why 1 minus 3 here bracket to power of 7, and then substitute the limit of 0. So 0 here, 1 minus 0 bracket to power of 7. Next, it will be equal to negative 1 over 7 bracket negative 2 bracket to power of 7 minus 1, and the final answer should be 129 over 7. For the next part here, when we integrate 1 over x dx from exponent to power of 1 to exponent to power of 2 here, it will be equal to, as we know, when we integrate 1 over x here, it will be equal to ln x, and then we have to substitute the limit of exponent 1 and exponent 2 here. And then after we substitute exponent square and exponent power of 1 here into x here, it will be ln exponent square minus ln exponent to power of 1. And then what we're gonna do, okay, since we know that after we apply the properties of logarithm to here, okay, we have to bring in front of ln here. So that's why it will be 2 ln e minus ln e, and the final answer should be ln e. And as we know, when the base of logarithm here is equal to this one, because of log exponent base of e here, it will be equal to 1. The next one here, when we integrate from 1 to 3, function of 3 exponent to power of 4x dx here, first we may factorize 3 outside the symbol of integration, and it will be equal to 3 the integration of exponent 4x from 1 to 3 dx. Next, as we know, when we integrate exponent 4x here, it will be equal to exponent 4x over 4. And then substitute the lower and upper limit 1 to 3 here. The next one, we may factorize 4 over 4 here, and it will be equal to 3 over 4. So it is 3 over 4 exponent 4x from 1 to 3. The next one, we have to substitute the limit. First, when x is equal to 3. So substitute when x equal to 3 into this inside function, exponent 4x. So it will be equal to exponent 12 minus when x is equal to 1. So when we substitute x is equal to 1 into this function, exponent 4x, it will be equal to exponent 4. So after you are using your own calculator, you will get 1222025.1 The next question here, the integration of 3x squared bracket square root of x cubed plus 1 dx from -1 to 1. First, we may simplify this one. Square root of x cubed plus 1 as bracket x cubed plus 1 bracket to power of half. In this case, we may apply substitution method, or maybe we may apply this property when we integrate, okay, from a to b, f prime x here, and then f x bracket to power of n dx. It will be equal to f x bracket to power of m plus 1 over m plus 1. So that's why, if you notice that inside this bracket x cubed plus 1, when we differentiate x cubed plus 1, we're gonna have 3x squared. So that's why we may apply this property. Or maybe you all can apply substitution method. In this case, I will apply this property. So next here, as we know, when we apply this property, here the power is half, and it represents for value of n here. So that's why it should be n plus 1. So half plus 1 should be 3 over 2, and then we have to divide by 3 over 2 on denominator side. So that's why it will be x cubed plus 1 bracket to power of 3 over 2 over 3 over 2. And then we have to put lower limit and upper limit. Next, after we simplify, it will be equal to 2 bracket x cubed plus 1 bracket to power of 3 over 2 over 3. And the limit is from -1 to 1. So next here, after we substitute the limit here, we may factorize 2 over 3 bracket x cubed plus 1 bracket to power of 3 over 2, and it is from -1 to 1. After we substitute the limit from -1 to 1, first we have to substitute when x is equal to 1. So that's why 1 cube here is equal to 1 plus 1, and then bracket to power of 3 over 2 minus, when x is equal to -1, as we know, -1 cube is equal to -1 plus 1 equal to 0. So that's why 0 here. And it will be equal to 2 over 3 bracket 2 to power of 3 over 2. And our final answer should be 1.886. Next, example 15. If we integrate fx dx from 1 to 5, which is equal to 8, and the integration of fx dx from 5 to 9, which is equal to 6. Find, for part here, the integration of fx from 1 to 9. As we know here, the limit is from 1 to 9. And we may express it as the integration of fx from 1 to 5, and then plus from 5 to 9. As we know that the integration of fx from 1 to 5 is equal to 8, and the integration of fx from 5 to 9 is equal to 6, and we may express as 8 plus 6, and the final answer here should be 14. Next, for part B here, okay, the question is asking the integration of 3fx dx from 5 to 9. First, okay, we have bring 3 here outside the integration, or we factorize first. Next, okay, since we know that when we integrate fx dx from 5 to 9, it will be 6. So that's why the answer or the solution first will be 3 times 6. And then the final answer will be 18. Next, for part C here, when we integrate fx plus 2 bracket dx from 1 to 5. So it will be like this by using our previous property of integration. So it will be the integration of fx dx, okay, from 1 to 5 plus the integration of 2 dx from 1 to 5. So since we know that when we integrate fx dx from 1 to 5 will be 8, and then plus the integration of 2 dx from 1 to 5. So this one we have to integrate, and it will be, okay, the integration of fx dx from 1 to 5 will be 8, okay, plus with the our second term here, when we integrate 2 dx here, we will have 2x, and then the limit is from 1 to 5. We have to substitute each of this limit, and it will be 8 plus 2 bracket 5 minus 1, and then final answer should be 60. I think that's all for our chapter of integration here. I hope you all success. Okay, you all, this is the end of chapter 2. So I think this is end of our lecture from chapter 2. Thank you, you all. Bye.